Okay, now we're going to talk about the indeterminate powers. Indeterminate powers are indeterminate forms that cannot be directly applied the L'Hopital rules. These are 0 to the 0 power, infinity to the 0 power, and 1 to the infinity. We should see this as a function elevated to another function so that we can apply the natural logarithm rule in order to rewrite the expression and be able to use the L'Hopital rule. Okay, here's a clear example in which we should apply the L'Hopital rules, but first we should apply the natural logarithm rule. It's a limit when x tends to infinity of e to the x plus x all to the e to the x power. So if we evaluate, it's e to the infinity plus infinity all to the 1 over infinity power. So if we write it, it's infinity to the 0 power. And this is an indeterminate form, but we cannot apply directly the L'Hopital rules. So we should rewrite it using the rule we see before. So we say e to the x plus x is going to be our y. Y it's e to the x plus x to the 1 over x. So we apply natural logarithm, and it's natural logarithm of e to the x plus x all to the times 1 over x, because we already lowered the power. We rewrite this, and now we can apply L'Hopital rules only if it's 0 over 0, what we evaluate, or infinity over infinity. So we substitute, and it's e to the infinity plus infinity all over infinity. It's infinity, so we can use L'Hopital rules, and we derivate, and that's why we derivated here, and it's limit of when x approaches infinity of e to the x plus 1 all over e to the x plus x. Now, this we're gonna evaluate it again in order to see if we can continue applying L'Hopital rules. If we evaluate, is e to the infinity or e to the infinity plus infinity, so it's infinity over infinity, so we can continue with L'Hopital rules. Now, in this case, as I mentioned before, if we evaluate, it's infinity over infinity. This means we can continue with the L'Hopital rules. We can apply this anytime that it's only infinity over infinity or 0 over 0. So, limit when x approaches infinity of e to the x plus e to the x plus 1. This is the derivative of the last expression. So if we evaluate this again, it's going to be e to the infinity over e to the infinity again, which is the same as infinity over infinity. So it means we can use L'Hopital's again. We applied it again, and it's e to the x over e to the x. This is the same as 1. So 1 is the answer, but this hasn't finished yet. This is really important because this only means that the limit when x approaches infinity of natural logarithm of y is equal to 1. We should continue in the next section. Well, we already know that the limit when x approaches infinity of natural logarithm of y is 1. But what is the limit when x approaches infinity of y? So we should write that limit when x approaches infinity of y, it's equivalent to say that it's limit of x approaches infinity of e to the natural logarithm of y power. So we already know what's natural logarithm of y, that it's 1. So we substitute, and it's e to the 1 instead of e to the natural logarithm of y. So the answer is e to the 1. So we can apply this anytime that we get the function of above in e to the power that it's the result of natural logarithm of y.
So the rule of L'Hopital is that the limit when x approaches to a is the first derivative at the top and then in the bottom. So the second step is that we need to subtract this expression to apply the rule, and it will be 1 minus cosine of 3x over x squared, and then we evaluate, and when we evaluate the expression 1 minus cosine of 3, we obtain like 0 over 0, so we can apply the rule. And the third step is get the derivative of the top and then to the bottom, so it's 3 sine of 3x divided by 2x, and then we evaluate and we obtain an indefinite value. So we need to apply the L'Hopital rule again. So is limit 9 cosine of 3x over 2. This is the second derivative, this one. And then we evaluate, so we get 9 cosine of 3 over 2, and we obtain 9 over 2. And this is all that we have to do, and thank you.